All right, good morning. So we're taking out homework first. This was from page 42 to 43, I believe. And I think we did like one of the problem solvings and then even or odd on the lesson 18. All right, I also requested calculators for today. So from this point forward, please take your calculator. Okay, so tell me what's what. No, you probably did even or odd, so I don't know. Okay. So you did both the problem solving or?
Yeah.
Okay, let me see. Either they were thinking of the wrong questions. So it was either this one or that one, and then these even or odds, the 1 through 20 even or odds. Oh, okay, gotcha. So yeah, these were the, like, who did these in class? So yeah, it was this one or this one. And then. Commercial here. Need to finish those, so let's talk about, let's see.
These two.
Okay. All right. We did 224. Okay. All right, so I need to finish that. Let's talk about what you did. You did number 2. Says a ratio indicates division, and that is true. We kind of talked about the fact that our fraction bar means divide. And then it says a ratio of 5 apples to 50 cents indicates that the cost of 1 apple is 25 cents. So if you think about it, if I'm able to buy 5 apples for 50 cents, will 1 apple cost 25 cents? No, that can't be true. I'm gonna be mad, like, wait a minute, let's there's some special discount for buying more apples. If 5 apples are 50 cents, then I'm thinking 1 apple should be like 10 cents. All right, so you need to go ahead and get that finished, and then Karis, I'll be looking for that assignment from you as well, ma'am. The sharpening skills, well, problem solving 1 or 2, and sharpening skills from page 42 to 43, 1 through 20. Again, it's like 11 questions total. Today, we are talking about solving ratio problems. So that's on page 43 or slide 43 on the slides. I try to make the pages coincide with the slide numbers for you, Karis, until you use a physical book. And sounds like a herd of elephants upstairs. All right. Okie dokie. So proportion problems are really very, very common, especially for like standardized tests. So we're gonna be doing our MAP testing here pretty soon, for the beginning of the school year. And then, of course, when you guys are getting older, so we're gonna be doing things like ACT tests and AccuPlacers for college. So good idea to kind of get the gist of ratio problems, because a lot of the questions can be solved with the ratio. And they can be solved pretty quickly. So in our notes here, we're on section 129, 1.29. We're scheduled to cover this in an introduction to percents, but with our time today, I don't know that we're gonna have time to do both. So we're gonna kind of focus in on solving ratio problems today. That's another reason why I don't have your assignments on your assignment sheet, because it seems like I have to keep switching them. Like, I don't want you to do something you haven't went over in class. So that's why you don't see your assignments on that assignment sheet. I do apologize. All right. So last time we talked about a proportion, basically looking like this, like a ratio equal to a ratio. All right. And we were able to solve these when there was one piece missing. So for example, the one we just talked about the 5 apples being like 50 cents. And then 1 apple being like how much cents, okay? This is the gist of a proportion, is that they're gonna give you 2 pieces that go together. That, okay, 5 apples are 50 cents. And then 1 apple would be question mark, you know, so they're gonna kind of take on this format. Once we're here, we know that we can use our cross products to solve it, you know, like this and like that, and kind of work it out. So this was what we have done in the past. So 5 times x is 5x, 50 cents times 1 is still 50 cents. And then we talked about how to solve for the x if it's multiplication here. This is usually our divide step last. So again, just a quick recap of what we did in the previous lessons. 50 cents or 0.5, I should have put the 50, sorry. Divided by 5 will give us 0.10 or 10 cents. Okay. What's going to happen today is that we get the story. They're going to, instead of just giving us the numbers and just saying, here, solve it, calculate it, now they're going to give us the story, and then we have to put it into the proportion. All right, so let's jump right in. We'll just kind of walk through their examples. So example here says, on a map, 5 centimeters represents 200 kilometers. How many centimeters are needed to represent 500 kilometers? All right, so that's the basic setup. They're going to always start you out with something first that goes together. In this case, it's 5 centimeters represents 200 kilometers. These 2 pieces go together, and you'll notice that they're listed here together on their proportion. The 5 on top, 200 on the bottom. Now, you could switch it if you wanted to, but to keep it simple, whatever order they put it in the problem, like the words, is where I put it in the proportion. So they said 5 centimeters first, so I put them on top. 200 centimeters per second, put them on the bottom. All right, now they're going to give you one other piece of info, and that's 500 kilometers, okay? So at this point, you have 2 choices. You could either put the 500 on the top or on the bottom. And I think we might have did some of this last year, a little bit, with proportions, I don't remember. But that if it's 5 centimeters on the top and like 200 kilometers on the bottom, and I've got like 2 empty spaces to choose from, and they give me 500 kilometers, Well, I'm gonna put kilometers across from kilometers. I'm not gonna put the kilometers across from the centimeters. So that can kind of help you figure out where to put that last piece. Oops, not another 2, it's supposed to be 5. So that would be how I knew to put 500 on the bottom, was because it matches up kilometers, kilometers. And we are looking for centimeters, because it says how many centimeters, so I know that's the question mark. Once we're here, we're just ready to calculate it out. Now, I did tell you at this point, you may utilize calculators, okay? And I'll be showing you all kinds of tips and tricks with your calculator. Which kind do you have? Let me see which one you got. Oh, awesome, I think this might be the same one you might have too. All right, so Karis, this is good. I don't know if you want this message on it, but but this is kind of the basic layout that Lolly has for a calculator. It's a Casio. So if you haven't bought one and you want to get the same one, feel free. Where did you get yours from? Good old Walmart. Yep. I think that's what Janai is too. So if you want to, grab one from Walmart, that's fine to have the same one. If not, that's okay. I'm pretty comfortable with most brands of calculator. All right, so with that, I'm going to show you a trick, a shortcut for solving these, okay? So I've shown you the long way, the multiply across, and write it down, and then calculate it. But because most of the tests that you guys are going to take, they will allow you to use a calculator at least for a portion, at least for the word problem portion. I don't mind showing you how to maximize their usage. Okay, so we are always multiplying the two numbers that are across from each other. And then in the end, we always end up dividing by the number that's across from the x. That's just kind of the process. We always end up multiplying these and then dividing by this one. So that's the shortcut. I would like to see you set this up for me, show me this, but then in your calculator, you will type in the following. We're going to take the 5 times 500, okay? And without even hitting equals, we're going to keep going. We're going to then divide that by the number that was across from the x. Because we follow the same pattern every time. We always multiply these together and then divide off the other one. All right, so if you type that in, Lolly, what did you get? 25/2. Okay, now your calculator automatically is giving it to you as a decimal, as a fraction. Change it to a decimal by using, I think, the SD button. Do you have an SD button on there? Let me look a little closer. That little SD deal, and voila. 12.5. Okie dokie. So Karis, again, if you have a calculator, if most of them will give you the decimal answer first, but a lot of them now are doing the fraction and you have to change it to the decimal. You can click the SD button and it will give you the decimal answer. It kind of goes both ways for our book. Sometimes they'll want the fraction, sometimes they'll want the decimal. It's not very consistent. I'll take usually either one, okay? All right, so let's continue. We know that this would be 12.5 centimeters according to our story. Let's turn the page and 44. All right. This one I'll talk you through, and then we're going to work the other ones. We won't work this one, we'll just talk through it. It says that the Greer volleyball team played 25 games. The ratio of games won to games lost was 3-2. So instead of saying, oh, 5 apples cost 50 cents, sometimes they'll give you a ratio. They're telling us the ratio is 3-2. With that ratio, it says how many games did the team win, okay? So the two pieces that go together, our ratio, I generally put those first. Let me see. Oh, I see what they did. Okay. Gotcha. That's why I wanted to include this in our discussion today. So we've got two pieces of info. We have our ratio and we have our total number of games played, okay? The ratio is a ratio of games won to games lost, because they told us that it was the number of games won to lost, which means that they must have won 3 games. That's the first number. And they lost 2 games. That's the second number, right? According to what they said, the ratio of wins to losses. Now, they want us to figure out how many games did they win if they played 25. Okay? So, I don't necessarily need the lost. I need the number of games won, and I need the total of games played. Well, if it was 3 wins and 2 losses, how many games did they play?
25 divided by 2.
We'll get there. We're not quite. If I just told you, oh man, we won 3 games and we lost 2 games, how many games would I play just with that ratio? I would have played 5, okay? So we're assuming that if there's 5 games played, 3 of them they would win. That's where they get this beginning ratio over here, okay? That if they played 3 games, sorry, they won 3, it would have been out of 5, okay? Because they told us it was 3 to 2. Out of 5 games, they won 3. The question they're asking us is, well, what if they played 25 games? So the top number represents how many games they won. The bottom is how many games they played. So where would our 25 go? Well, if 25 is the number of games played, it should go across from games played. Like that. All right. Then we use our same calculator skill that we know we're going to multiply the numbers that are across from each other and divide by the one that's across from the missing. So it will be 3 times 25 divided by 5 equals how much? 15. All right, so then that makes sense that, all right, if you pay 25 games, we would expect to win 15. If we do it the other way, like if I forgot to not put 3 over 2, it's gonna give you a weird answer that would not make sense in our story. So that's another way to kind of check yourself. Okay, let's jump right into our questions here before they call me for language class. Let's see, how you feeling today, Lolly? Should we do evens or odds today? Gonna go with the evens today. Question. Okie dokie, starting with question number 2. So this is practice problem 1.29. And we're doing numbers 2 through 10 even. All right, so pretty much practice problems are what we will do during class. And then practice problems and problem solving and sharpening skills are usually homework. All right, a team that played 35 games lost 2 out of 5 games. How many games did they lose? So we already know, starting out, it's gonna be a proportion. Okay, we kind of already get that. What 2 numbers do we know are gonna go together first?
35.
Okay, so it says a team that played 35 games lost 2 out of 5. So the 35 games isn't really part of that connection with 2. It was 2 out of 5. Does that kind of make sense? That that's the piece that kind of connects that it's 2 out of 5. All right. So I'm gonna keep it the order they gave it to me. 2 out of 5, we'll put 2. And then 5. All right. Now we've got this lovely 35. We have to figure out should the 35 go on the top or on the bottom. It shall go on the bottom. The bottom represents the total number of games played. And the top number was the number of games that was lost, because it said lost 2. So here are my losses, here are the total games. All right. Calculator ready, type it in, let's see what you get. See if the calculator skills are strong. No, not 10. Let's see what you typed in. Did you do 2 times 35 divided by 5? No, what did you do? Oh, you did 25. Oh, no, this one's 35. Yes. And because it's a story problem, 14 what is our answer?
Games.
It's 14 games. And we know that these are the games that they lost. How many games did they lose? They lost 14. All right, drop down to number 4. Mr. Owens traveled 623 miles in 7 hours. At the same rate, how many miles will he travel in 9 hours? Interesting. All right, so what are the 2 numbers that go together?
I'll put 18. 1.5.
Ooh, I'm thinking on a different one. You said 18 and 1.5?
I was on number 6.
Oh, okay.
The 7 and the 9.
7 and 9? Nope, they fooled you again. So it has nothing to do with like location in the question, or even like size of the number. Because it says that Mr. Owens traveled 623 miles in 7 hours. I know that these 2 go together. It was 623 miles and it was done in 7 hours. Then it says at that same rate, how many will he travel in 9 hours? So I know that these 2 are our match, or this is our beginning rate. And then we'll use it to find this one. All right, so I'm gonna keep it the same order, 623 on the top. I know this is miles, and then 7 hours on the bottom. All right, so our last piece of information is 9 hours. Where should we put the 9 hours? Definitely on the bottom, hours across from hours. So these last 2 both happen to be on the bottom. Not always the case, it just depends on what the unit is. All right, calculator skills ready. Type it in. All right, so he probably typed in 623 times 9 divided by 7. sorry, 801 miles. All right, number 6. A subway travels 23 kilometers in 18 minutes. At that same rate, how many kilometers will the subway travel in 1.5 hours? Okay, let's try it again. Don't let them fool you. Which two go together this time?
23, 18.
Yes, ma'am. Because it was 23 kilometers traveled in 18 minutes. Perfection. So let's put that in our proportion. 23 kilometers, 18 minutes. All right. Now, it wants us to figure out how many kilometers the subway will travel in 1.5 hours. All right, what's going on with that? Okay, so we're thinking bottom. Okay, why were you a little reluctant?
What?
I said, why were you a little reluctant?
Because we don't have the same. After.
Exactly right. So you are on track. They don't have exactly the same unit. On here, it says minutes, but in our problem, it says hours, okay? We need to make them the same. Because I know we can change hours into minutes. Yes. How many minutes in 1 hour?
60.
There's 60. So if I've got 1.5 hours, how many minutes would that be?
Oh. 60.
So we know the 1 hour, that's 60 minutes. In our half hour. You said 6 minutes? No.
60 over 120.
Okay, so you're doubling. That would be 2 hours worth of minutes. Okay. We just want to cut it in half. So I want to cut 60 exactly in half. What is half of 60? 30. So there's 30 minutes in a half hour. There's 60 in our full hour. So we know all together, we're gonna have 90 minutes. So this is what we'll put in our proportion because it has to be the same. Minutes across from minutes. All right, now we are ready to calculate.
$11.5.
11.5. Ouch. That's correct. Oh. They have a 0.5. They just have 115. Let me see, we typed in 23 times 90. And then divided by 18.
Well, I originally got 23.
Okay, where'd you get your 2 from? Never mind. So we put in 23 and 18 here, And then we got rid of our 1 1/2 by making that 90. So yeah, just 23.
I forgot to add the 0.
Oh, okay, that makes sense. That'll make sense why it's the decimal point. All right, and we know it's kilometers because it's kilometers across from kilometers. Wonderful. All right, let's see number 8. They haven't yelled for me for language yet. Maybe one more. All right. A pole that is 6 feet tall casts a shadow that is 4 feet long. At the same time, a tree casts a shadow that is 24 feet long. How tall is the tree? Okay, so which two go together? What do you think? You said 20 what?
26.
For the answer?
Yeah.
Mm. Good thinking. All right,
22.
22.
Um,
Nope, nope. So back to the drawing board. What two numbers go together?
um, 6 and 4.
6 and 4. All right, so I know that they're both in feet, but I see one is tall and one is long, so 6 feet tall. I'm gonna just mark it for myself. And this one long, that way it'll help me know where to put the other one. All right. Where's the other one gonna go?
At the bottom.
At the bottom, because it's 24 feet long. All right. Now we'll calculate and you'll see how close you are when you're using your mental math skills there.
$36.
36, yes. So it was 36 feet tall. They like these questions on the tests, the shadow questions, or like a link question where they're telling you, okay, well, this one has this with this. Well, how long would it be if this one has this? So this same idea, I see this a lot. And then of course with maps and stuff too, they'll say, okay, on the map, 1 inch represents this many feet. So then how many inches would it take for this feet? So these proportion problems will be used for all of those. All right, your homework. On the next page, the sharpening skills. We have 21 questions on there. This is on page 45. We will again choose evens or odds on here. So I guess I'll make it 1 through 20. That way, if you have odds, you're not feeling like you have to do the extra one. So we'll say the homework is sharpening skills. Sharpening skills, page 45, number 1 through 20, even or odds. All right, 1 through 20, evens or odds. So yes, if you want to, you know, kind of help you visually, I know we don't normally write in our books, but I'm changing our policy, but this is the last time this book will be used. If you want to mark in there, so you'll see which one it is, when I put it up here, feel free to do that too. So that this is the homework. You'll still put your work on paper though, but you can mark that it's going to be there, and that it's the 1 through 20, even or odds. Yeah. All right, I will dismiss you. I don't know if you're on break yet, but you have a leg up, and if you want to start the homework, you can. And Paris, we will see you later. Make sure I get this uploaded.
Bye.
See you later.